let's jump into SIEM and Splunk. So just a question again for people. What's your SIEM that you prefer, your favorite SIEM? Splunk, ELK, anything else that you're using or familiar with? Curator, okay. Rapid7, Splunk, ELK, Curator, Sumo Logic, yeah. Wasu, Sentinel, Splunk. Okay, so it seems like people are familiar with Splunk quite a bit. ELK, similar along those lines. To me, honestly, I don't have a preference at all. I just think Splunk is easy to install, even especially in our labs. So Splunk, Curator, ELK, whatever you might be using, you can translate what we are doing here probably in every single in any SIEM. So I don't want to make you tool dependent. It's just the preferred way of doing things here because it's simple and easy. So for those who are not familiar with it, a SIEM basically is a security information event management system. It centralizes and aggregates logs at a centralized place. So we aggregate logs at a centralized place, and we can then look into these events. And those are like millions or billions of events, and it's pretty effective, right? Some of those main players are Elastic, Splunk, SIEM, like Curator, as we've seen before. And the real-time monitoring, alerting, obviously, if we have any suspicious events or rules that are detecting something, of course, that's one purpose of it. But it also allows us to perform some powerful searches and analysis and reporting and dashboard and things along those lines. So just anything really that exists as a log can be pushed into a SIEM and then from there analyzed. This is kind of the architecture, and that's true for most architectures of SIEMs. Basically, you need endpoints, you need applications to forward their event logs to the server, and the server contains an index where the data is going to be normalized and stored. And then you have a search head, which is basically the interface that you can use to search for events and alerts. So this is what we're going to be using, the search head, to look into these things. And with Splunk, the one thing that I just like about it is, again, I was mentioning it, it's pretty simple for our lab. It has a free license option. So for our lab, the free license works totally fine. A few things where we can't just install particular apps or parsers, things along those lines. But for a small lab, the free license still works great. And that's kind of my preferred way of doing things. Now, the one thing that we need to be familiar with if we perform analysis in a SIEM is what kind of data are we looking at, right? So that's, it's all great if we have a Splunk search interface in front of us, but what do we actually need to know in order to get something useful out of it? First of all, the syntax. And the syntax is actually pretty cool nowadays. You can use Sigma rules, for example, that will allow us to translate the same search queries across different types of SIEMs. We cover those in other courses, but just saying it's not so much just becoming familiar with the syntax and the queries, but actually it's about the data that we're looking at, understanding what we're looking at and how we can find out something interesting. And for this, I have a list of some of the favorite event IDs that we are dealing with, especially in our case here. So those are all Windows event log specific events. So we have in Windows event and Windows endpoints, we have event logs that are generating events that are of different nature. So there's an event log that captures PowerShell activity. We have PowerShell 400 event ID, which basically logs when a PowerShell process or an engine is started up. We have a 4104 PowerShell script block log, which I was just saying event, which I was saying earlier. We enabled that so that we can actually get more visibility into some of the payloads that might have been executed as part of a PowerShell process. Then one of my favorite ones is also 7045 service installs. Lots of malware, lots of attacks usually rely on service installs. So this is usually one of the first ones that I would look at if there's anything malicious that happened, especially in terms of lateral movement. Not so much today, but just generally, this is a really important one. We have scheduled tasks, right? Anything nowadays likes to execute things with scheduled tasks, either legitimate, non-legitimate kind of for non-legitimate purposes, but scheduled tasks are often created as part of executing something or as a part of a persistence mechanism. So one of the main things to look into pretty quickly in an analysis, if you have any suspicion and that there might be persistence as well. And then for increased visibility, and this is why I was mentioning Sysmon earlier, Sysmon just basically covers a lot. It's very specifically made for the information that we are looking for. Event logs are not specifically made just for security purposes. There's also a security event log that logs user logons, logs off, log offs, and things along those lines. But Sysmon really is the one that actually captures so many events. For example, process creation. Any process that gets created, event ID 1. Any network connection that was created, event ID 3. Any file that was created on the system, event ID 11. A DNS request, a query that was initiated, event ID is 22. So as you can already see, as part of an attack, these 3 or 4 events already cover a lot of information that we are typically looking for. So Sysmon is awesome. Technically, with Sysmon, you have 29 different event types. As, you can even see when registry keys were created, modified. You can see so many more things when processes were terminated, when I don't even know, 29 more different event cases. And this is extremely noisy. And this is the problem why we don't have Sysmon on all the endpoints, obviously, as people that are working in SIEMs here know. It does a lot of data, but I would rather have Sysmon locally on a system, even if it's not in a SIEM, forwarded to a SIEM, because if it is expensive. I would rather have Sysmon somewhere, because if I have to go back and look into the system of what happened, Sysmon basically tells the story, and then I don't have to do just the whole forensic analysis and parsing out artifacts and then trying to get some of the information that would already have been captured by Sysmon anyways. So this is why Sysmon is pretty awesome. And Sysmon also has to be configured. So you can configure it to make it more or less noisy. You can configure it to capture just one of these events or none of all of them. I would always say, at least, if you only capture process creation, that's, one of the main things that we are looking for. So there is configuration files. One of the most famous ones, as people might know, is Swift on security. If you set up Sysmon with the Swift on security configuration file, this is a pretty good template that allows us already to tune out a lot of false positives, a lot of noise that we don't want to log anyways, but it still needs some tweaking. So in a production environment, I would not just recommend to put it in there, but it's there and it's a good starting point. Actually, let me know, not a question for the audience. I'm actually curious, who here is successfully using Sysmon in their production environment? Or not even successfully, just generally. Is anyone here using Sysmon? Limited, yes, using it. I wish. I use Sysmon and love it. Yes. Limited every day. Okay. Yeah, there's different templates out there. Of course, it's not the only one that you see here. Is good, a lot of noise. Yes. And so this is the difference here, right? We are looking into a lab environment. So basically all we see in Sysmon is interesting. If you have millions of data points and we have to look at, just find a few dozen events that are actually malicious, then of course the story changes, right? Right here, we are looking at a lot of true positives. So the things is easier, but this is where we're learning, right? I would love to have everybody get a lab and be able to look at a lot of true positives and then apply the knowledge in a production environment, then not looking at it at all. If I'd say if those 4 event IDs that I mentioned in the slide is enough. Technically not, but this is relevant for our case. And those are my main favorite ones, especially for the case that we're looking at here, but things might be different, depending on the scenario. So I wouldn't know. I would not say this is the one thing you should look into. I would say if you only have one event ID, just log process creation, because that's the most important one. There's other ways to do it too, of course, without Sysmon, but that's just an important one. So you can also do 4688, I think. Somebody was just typing it. You can also do that too. There's some differences in the context of what's captured, but I don't think, if you don't have to deploy Sysmon and have a 4688 event captured instead, that's totally fair. Right. Sysmon has better process command line capturing, things along those lines. Yep. So people already know what I'm talking about. Awesome. So just some of the events that we want to keep in mind here with the investigation. Actually, here I have a quick template. Just if you have one thing that you want to capture as Sysmon, as I was saying, if you just want to capture process creations, here's a template that actually just captures process creations where the EXE, or the executable, is just the PowerShell. And then in the command line, all we want to see is reg. So reg is the registry tool utility. So if PowerShell executes registry utility, this is the Sysmon configuration for just capturing that. And if you want to capture nothing, such as you don't want to capture process termination, you include nothing. And that means we basically are not capturing anything that in terms of process termination. But process creation, this is associated with event ID 1. If you just capture PowerShell, I know a lot of organizations have a lot of PowerShell traffic and noise, but this is a way how to create a template and tune it down, right? I would rather have this somewhere than nothing at all. But this is, again, just an example of how to create templates for Sysmon. So let me know if you have questions. You can also throw it into the Q&A. But other than that, we'll jump into the demo. Here's my workstation. Like I said, of those particular, the event logs of the case of particular this client 2 system are in my Splunk instance here. I've imported those. I've actually captured those in real time beforehand, exported those in my forensic workstation. And so here is what we are looking at. There's a particular index, and I'm looking at 4,000, roughly 4,000 events that were captured during that time frame. So as you can see here, the time frame here says 1 hour and 3 minutes. So this is just a time frame of 1 hour and 4,000 events that we are going to be working with here. And the first thing that we should do in Splunk or in any SIEM that we are getting into ourselves, if you work in-house, you probably know your data and your SIEM much better than anything else. But if for me, for example, as a consultant, it was always tricky. You just jump into a case in an environment that you've never seen before with a tool that you've never seen before. Good luck figuring out what looks not normal with all the data that actually is happening there. So the first thing I usually do is get a lay of the lands, right? What kind of data are we looking at before we can actually drill down into what do we know and how can we go from there? So I have, of course, some queries here in my cheat sheet, because otherwise you don't want to see me typing and mistyping things. The first thing I would do is when I look at the logs, we have, as I already know, there's only one system that we are looking at, which is called client 2. So first of all, I want to see a lay of the land of what are we capturing here, which is a pipe into the stats count by and then the log name, so that we can actually just filter by, show me all the log names that are available. So which logs do we have available as part of our investigation here? Then I can even see how many entries those logs have on the side. So if I sort those, I can already see we have Microsoft Sysmon operational log that has about 3,000 of the 3,900 events captured. And then we have system, which has 160 logs. We have some Windows events. Then we have PowerShell that has captured 88 events. We have security that has captured 85 events, and so on. There's all these Microsoft Windows event logs that most of them, there's task scheduler, but most of them are not even relevant to us, right? They're not really security specific. They're not really too interesting for us in order to investigate those things right now. So as you can see, we have mostly Sysmon logs, and then we have some system and some security and some PowerShell. So this is what we can already work with, right? This is something that is really good. That's good to know. We can go deeper and drill deeper on that. Let's see if I can make things a little bigger. People are saying it's a little small. Okay. All right, I'll try this, but now it's getting there might be a lot of scrolling. So this is bigger. Hopefully you can read that. Obviously, that's most important. And so what do we have now? We know the data. We know about the alert. Our alert was that there was a windowsupdate.com URL that was being used to download something malicious. So this is our only indicator that we can use to pull on, right? So first things first, that's probably what we want to throw in there. If we go ahead and just do that, we can type windowsupdate.com and just see what sticks, right? We can do wildcards left and right so that we not restraining it to anything. We just see what do we have available in terms of windowsupdate.com. And from there, one thing I always like to do is piping it into reverse, because that basically shows us from oldest to newest. And that's more, to me, more easier to look into, right? We can always understand this happened, then this happened, then this happened instead of reverse. So now I've been getting 5 results, 5 events out of those 4,000 events that we have captured. And we have Windows Update here, and we have the time when an event was captured. We have the log name when the captured event. We have the event code, which is this one where we have, this case, we have a sysmon log that captured event code 22. If you remember from before, that's a DNS query. And that makes a lot of sense, right? If you start connecting to a malicious domain, you first have a DNS query to get the IP address in order to connect to it. And all these things were captured within 7 minutes. So we have 5 events that happened within 7 minutes and nothing else, because my filter here is on all time. So we're not restricting ourselves at this point. So what we're seeing is there's a DNS query that was made by host 2, client 2, because we are basically filtering client 2. And it was made by Firefox exe and the user Alice. Okay, so this already tells us, okay, Firefox tried to connect to a windowsupdate.com domain. We had a DNS query that went to somewhere, and here's the query result. So here we already have the IP address behind this windows.com, windowsupdate.com URL, which is interesting. Then we have another one here. Let me see, DNS query. And then from there, a minute later or so, we have another sysmon event, which now here's 15. And this is saying file stream created. So that's not a good sign, right? If you have a file stream created, that means we are downloading a file from somewhere. In this case, we can already see we are downloading a file stream for user Alice, and it's using Firefox exe, and it's called, the file is called CEUs Alice downloads update.exe.hda. That's the file we're downloading. And then there's also, the stream tells us that is actually :zone identifier. That's an alternate data stream. If you download files from the internet, Windows automatically also creates a zone identifier, which basically indicates technically also where the file was downloaded from. You can see the zone transfer content in here. So if you look closer into the alternate data stream of a file that was downloaded from the internet, it's not just the exe.hda, it's actually zone identifier. And then we can see the source, the referrer, the host URL where this file was downloaded from, which is pretty cool. And that already gives away a lot, right? Now we actually know who downloaded it, what, when, where, and how. And now we probably just need to go ahead and look for what happened with this file, right? The file stream was created. We don't have evidence of execution. We just see this is the DNS query, and this is a file stream that was created. So let me show you a few more of these. Now we know there's this malicious file. And so when we just look for this update.exe.hda, we can see, we actually have this twice now, but we can already see that we have 6 events now. And who captured this? So which log? We have sysmon again. Everything, of course, sysmon. So imagine without sysmon, we wouldn't have seen any of this yet. Event ID, event code 11 means file created. So we have now, file stream was created from before. Now we have evidence Firefox created update.exe.hda. Now here's the file stream that occurred again because update.exe was a match. Then we have the zone identifier file creation over here, and then the file stream associated with it. And then this is actually new now, which is the most interesting part. We have event ID 1 and process create. And so this means now, if you look at the timestamps, 1 minute after the file stream was downloaded and created, we basically have a process creation event. And the process creation event happened to match the update.exe.hda. So who executed it? Let's put it this way first, Alice. Explorer.exe. So if you have an Explorer.exe as a parent, you basically that means the user was logged on, opened a Windows Explorer, and double-clicked on the updated.exe.hda. And that just executed basically as using the mshta.exe file. So that's a living of the land, or that's a binary, basically part of Windows that can help to execute HTML code. If you look at the mshta, what it can do, so there's a couple of living of the land resources out there. We can look up Windows binaries and what can be done with those. One of them is lolbas, the project.github.io. This is one of my favorite ones. This one. If you're not sure about a file, about a particular executable, what it can do, it can actually, in this resource, tell you what can be done with it in terms of security events. So it can execute certain things, it can be used to download certain things, and so on. So just saying, not everything needs to be in your head or stored in your experience, but not everything has to be off the top of your head. You have resources available to kind of look those up. And going further down, we basically now can see Windows Explorer executed update.exe, which was executed by mshda. And then from there, another process was created where mshda now is the parent. So here's the child. Over here is the parent process. And this parent process executed another process. We have parent information here. We have child process information here, where we basically have the process ID that was executed. We have PowerShell, which is the child process, and the command line captured that PowerShell executed this stuff, right? And so PowerShell, no profile, and window hidden and so on, encoded, payload, this and this and this and this. And this is something we've seen before last week when we looked into the update.exe.hda. So that was basically contained within the update.exe.hda to execute a PowerShell payload. And now when we look into the PowerShell payload, as we have done in the previous session, can copy that and decode it just real quick for everybody who hasn't seen it yet. You can use CyberChef, convert it from base 64, remove the null bytes because every other byte is kind of can be skipped, and then make it pretty, and then maybe a little bigger, right? And then from here, this is what update.exe.hda really executed. This payload is now decoded. There's some PowerShell checks, but doesn't do anything. And then from there, you can see there's this web client that is going to be generated with something that appears to be a user agent with something encoded again, /login/process PHP. It adds the user agent. And then we have some kind of encoding. So this is probably payload encryption. That's the encryption mechanism to exchange data with the server. And then it basically executes the web client to connect to something that is probably in here. Over here. So here we have the malicious IP address. This is our IP address that this particular binary executed a PowerShell process to connect to this server and then communicate with the server by establishing some encryption. And that's what we found out here, right? This is kind of the main process that we are looking for. And so the one thing why, let me scroll up here a little bit. The one thing why this is actually an important event is that this basically started everything, right? It looks like this is the PowerShell process that is being used to connect to the server and to communicate with the attacker and to execute whatever the attacker wants to execute. So this is how typically stages work. Stages are something that initially downloaded to facilitate the connection to establish a beacon, or also called agent, to connect to this malicious system. And when this has happened, this process probably stays in place, usually, in order to communicate with the attacker. Luckily for us, we have a sysmon log which captured the process ID, which is great, but there's a lot of process IDs in an environment. we also, although, have a unique identifier for this process, which is the process GUID. So if this particular event happened and we know that this process is now running and probably communicating with a suspicious malicious server, we can follow the entire process by using the GUID as long as we have sysmon and process GUID field available. And that's something that I would pull on right away, because that basically tells the entire story of this particular process and what happened with it. And I have that available, lucky for us. And then let me show you how I would go about it. So here I just copied this particular process GUID, the global unique identifier for this process. But keep in mind, if this process executes, we want to see the process itself. But this process, obviously, as attackers are executing commands with it, might also execute child processes. So I'm also interested in the same process GUID where this is the parent process GUID. So basically, this process where it's the process itself or a child, or it's the parent of a particular child process. That's everything I'm interested in. And then from there, for now, let's just look at that. And now we can see there's a lot, like almost most of our events that we captured, actually 2000 events almost within the span of 22 minutes, is this particular process responsible for those events. So as you can see, this is the execution again. And then when it PowerShell executes, what you typically get is a PS script policy test PS1 file that is being created. So whenever PowerShell executes, that's what you get. And that's a good indicator actually for PowerShell executing. So if PowerShell executes out of a random process, if this file was created, it's actually an indicator of it. And then from there, what else do we see? We have network connection, event ID 3, sysmon 3 network connection detected. And then we can see this PowerShell process here was actually connecting to source is client 2, destination. Here we got the 3.140.33.120 destination IP address and 9001 as the destination port. So this is basically communication that's going on. We can also see the host name, which appears to be an Amazon EC2 image. And this keeps probably going as we scroll down. Event ID 3, event ID 3, event ID 3. Every second we have event ID 3. Now that's clearly a suspicious sign of probably beaconing, because every second, somewhere around every second, the system seems to be checking in with the server. So we can see about 80 or so events every minute, which goes down to about a second and a little more network connections per minute, which is a very constant kind of beaconing pattern. Now, to sort this out, because we already know that there's network traffic going on, I can also do just, let's remove event code 3 for now, because I know network connections are being established. Okay. But what else happened? This is more interesting even. Did this process execute anything else? And here we already see that this is the first process again, where this is the process creation of this actual PowerShell process. We can already see command line. This is the payload that we already looked into. And then what else happened? So there's the PS script policy test file, but 57, 59, 2 minutes later, we can see, and this is the power of sysmon, we have registry, we have an event that captured registry value was set. So now we can see actually there was a registry value set by this particular process. And into this registry value, we actually had the command line that was executed was basically PowerShell and then some kind of script-ish kind of stuff into the HKU for a particular user, registry Hive, software, Microsoft, Windows, current version, run updater. Now, who knows what this location might be or what this might be doing? Anybody know what this current version run location might be doing, or what this is used for? Runs on startup, run key persistence, setting persistence. Perfect. Yes, so exactly. This is a user SID. So when this user logs on, this updater key has been stored into the current version run key, which is run is for the is a persistence mechanism. So anything that's stored in a run key gets executed on logon or on system startup, depending on which run key. But now we can see that this is a clear sign of persistence because there was some PowerShell stuff stored into run/updater. Updater is just the name for this particular key. And we can see here what it's doing. So when updater executes upon logon, it executes PowerShell with a payload of X. And X is this. X is going to be the payload that is being retrieved from somewhere else. There's actually a debug field in there in the registry key. So now this is a little tricky, but it's also, that's the reason why it's actually made this way. There is a run key persistence mechanism that is going to, upon logon, execute PowerShell that pulls data from this particular key and then executes it. And we can already imagine that this is like just persistent. So it would probably be another stage or an agent that actually facilitates communication with our command and control system. So this is a persistence mechanism that we just came across. And then we can also see, again, always sysmon, we can also see a minute later, there was something created where our process seems to be the parent process. And then there's whoami exe/groups. So whoami was executed. That's a part of a lot of scripts these days that might not have not been done manually. There's more whoami here again. And then another thing, scheduled tasks was used to run this particular tool. Now that's pretty interesting. Doesn't tell us much. This is at this point not clear. We can absolutely follow up on it and look what this means and what this does. But at this point, it doesn't really tell us anything. It was just saying this malicious process executed scheduled task with this parameter that we can look into later. But that's already one way to look into things, right? Now we know that a lot of things, right? We already know that PowerShell is being executed with this particular payload and so on. And this is just the one process that we've been looking into. There's nothing to say that there's more processes that might have been malicious, right? And actually, we have this one, this scheduled task. We don't even know what this guy is doing here, right? Now, following up on this one, we might be able to figure it out. We might actually see that this one might be triggering something that is certainly interesting for a little later. But if we dig deeper, we would then find out about some more information. I'm going to skip a few steps here because that would just make us dig deeper and deeper otherwise. But one thing how we can also see where else might this particular payload have been apparent from is by simply just throwing it into the search, right? So if you throw this one into the search, it's just a snippet. It's just the beginning because this part doesn't change too much in our payload here. And I'm just blanking out the 600 PowerShell events here because that's going to be too much, but just looking for, hey, where do we see this kind of pattern? We can't copy the entire payload because that obviously changes, but the first few bytes usually are always the same. That's true for Cobalt Strike beacons. That's true for PowerShell Empire and so on. So now we actually have 23 events where we have our process. And then we also see that Windows PowerShell log as an alternative now has an engine starting up. So a PowerShell engine starting up which captured the exact same event. So this process executed. And then we have 4104 script block logs, right? Script block logs is basically, like I was saying, capturing payloads of PowerShell executions. We have a payload here. And here is another one. And those are independent, but if we look into this one, we can see that there was something stored in a registry again to be executed. And if we look at this payload here, this was clearly a script that was being run. And the script itself already, the name already gives it away. Invoke environment bypass. And if we look that up, or if you look up the script, this is obviously something we can easily do. It would set a registry, we'd set payloads in a registry key, execute it, and then there's some trickery to basically perform UAC bypasses. So basically user account control bypasses. So this is an escalation of privileges so that we have an elevated command shell after this is executed. So this is the entire payload. The script can be looked up online. It's actually part of PowerSploit, I think. And then we have a new engine that started up. After this, we have a new PowerShell process that executed. And then here we have, I think this is actually the new one. No, this is the one we saw before. But long story short, if we follow up on this, we can see there's more. There's who am I executions. And then this actually might be already a new one. So yeah, this is already the new. Yeah, this is the new kind of process GUID. Let me double check. No, this is the old one. We are basically looking at two different PowerShell processes now. And the one I should want to identify is, there it is, I think, yes. This is a new one. So now we have a new process creation where PowerShell was executed. So this is the Windows Update registry key where stuff was stored earlier. Now it was actually the parent process that was executed. And now we have integrity level high. So this is an elevated command shell or PowerShell process that is running now the same agent as before with the new GUID. So now we have a new GUID. And that's what I wanted to go to. So this, I just wanted to get to showing you, hey, this is now how we can find out about it. And then, of course, doing the same search using the new GUID to see what this process now might have been doing. And if we do the same thing again, the new GUID for process GUID or for parent process GUID, because we want to see everything that it does, except the event code 3, which we don't need the network traffic noise. Now we can actually look into, well, this is the process that was created. Now we have PS script policy test file creation again, as always. And then a minute later, we can see that this process as parent process has created scheduled task process where scheduled task was called to create on logon a task called updater to execute PowerShell and invoke payload that is stored in software Microsoft Network Debug. So long story short, this now is a persistence mechanism again, because scheduled task, there was a task created that is going to be executing every time on logon that is going to execute PowerShell where the payload is being retrieved from this registry location. So again, you can see the payload is not in the scheduled task. It actually gets pulled from this network registry location every single time. Software Microsoft Network Debug. So another similar way as we've seen before, right? This PowerShell framework tool here that we are dealing with, command and control framework, likes to store stuff in registry keys and then execute things from there. So we have another persistence mechanism. And then we have a DNS query to a domain controller. This is our .10 address, this is internal, nothing that we have context for at this point. But we can see there was another PowerShell process that executed, which we don't see because there's a PS script policy test. So this file was created, somewhere a PowerShell process was created in a different process probably. Maybe potentially some process injection that happened at this point in a process that we don't capture here, but we can see a PowerShell process executed. And then from there, a few executions. So this agent executed, this PowerShell process executed system info.exe. That's clearly a reconnaissance and discovery tool. So this is something that gives us a lot of information about this system. And then now we're getting to some really suspicious, interesting stuff. This process was responsible for executing a child process that was PowerShell within C/temp and running PowerShell with the command compress archive, alice documents, and store it as 1.zip in the temp folder. Yeah, people are already taking away in the chat. That's literally what we want to be looking for in any term, in any case of a potential data exfiltration. Staging. Data usually doesn't get copied outside of the environment from a server that it's in. Most of those servers or systems don't, file shares don't even have internet access. You need to grab those files, you need to put them somewhere, stage them, archive them, and then copy them outside the environment. And this one here is exactly what has been happening. There's a temp folder, and this temp folder here was used to store 1.zip, where 1.zip was basically Alice's documents. Everything that Alice had in her documents folder was put into a zip file and stored in temp. So what next? After this happened, well, that's sad. Now we have PowerShell remove item path 1.zip. Remove item, that's PowerShell command for deleting this particular file. So this now means that we have no evidence. This is kind of, deleting evidence of data staging and exfiltration. The attackers here removed and deleted 1.zip. So you won't be finding it on a file system anymore. You might have other forensic ways to analyze and find out about it, but this one here, not there anymore. This is actually just traced by logs and some other ways how we could look into this. So now 1.zip is clearly our data exfiltration point that we are looking into the stage data there. And we have a few more things here. Who am I was executed, the domain, a DNS query, nothing too interesting. So I think this one here already, we have scheduled task persistence. We have a second agent that we found out. We have data exfiltration that we found out. A lot of good stuff. System info for discovery. That's kind of what I would look for in terms of a potentially compromised system with looking for, hey, is there any data exfiltration and so on. And I know we have just been talking about sysmon logs. And this is basically the clue here, right? Without sysmon logs, you've seen there was a PowerShell process, a PowerShell engine that was captured. There was also a script block log. There was a payload that was captured. And that was it. Like we wouldn't even be seeing anything else other than that, unless you have network logs where you might have firewalls and proxy logs that might help us to see what's going on here. But sysmon here, I mean, there's a lot of data, and hopefully this was not too confusing and just clear enough to see, hey, this is kind of pulling the strings of the first thing this thing executed, then another thing executed, and this is how we can correlate things. And basically, we're already giving away most of the case, right? By just finding those things with sysmon. Yeah, thanks for the feedback. Seems like people are liking it. I appreciate it. Thank you. A few things. How can we, quick questions on what about the initial compromise? So the initial compromise, obviously everything started with Alice downloading update.exe.hda with Firefox and then executing it. That's what started the PowerShell process where all the malicious stuff then happened. Now, a few things that we can do, when we potentially do not have sysmon available, I would look for scheduled tasks, like I was saying earlier, right? This is just a common persistence mechanism that is being used. So if I look for scheduled task log event ID 106, we have task creations, and there was Firefox creating tasks. And here we actually have this updater task that was captured by the task scheduler event log. So if we want to know what this guy is doing, it's not in log. We actually will have to look into the updater task itself and parse it out and see what's happening there. So this is why forensics is so important too, right? Because in the log, if we don't have sysmon, we might have seen that there was a task that was created, but we still don't know what it's doing. So we will have to dig into the tasks and parse out the updater and see what's in there. Something for next time. Then PowerShell, right? We've seen kind of what happened with PowerShell. So if we just look for the PowerShell log events that we've come across where we have no sysmon, but just PowerShell logs, event code 400, there is a bunch of things. So 400s, there's also 600s, but 400s are cleaner. So we can see that there's some PowerShell events that happened that were captured by starting up PowerShell with this suspicious payload. There's also PowerShell that with executing stuff from the update registry place, and then same things over and over again. So PowerShell command. So actually, this is interesting. We found out that the PowerShell command to compress archive 1.zip was captured by 400 events. So that's good. That would have been one way to look at it. And then also PowerShell command for remove the 1.zip file. So that's actually not too bad. That's at least some evidence, right? And that's it. That's all the logs we have here. Now, that is just the beginning, right? There's a few things with Sysmon, obviously, magic we can do. And we are just looking at events here, right? We have not even used the power of Splunk. What we are doing is log parsing. And so a few things that we could do, for example, don't want to give away all too much, but we cover those in other courses. But the one thing that I would say is probably interesting, some powerful stuff from that Splunk can do is sorting, stacking, least frequency analysis. So for this one, for example, all we want to do is looking at the process creations that Sysmon was capturing, except from Firefox, because Firefox is so crazy noisy. And then just give me all the command lines that were executed. And if I just do that without knowing anything about the case, all we do is now we have process creation events and just showing command lines that were associated with it. And then we have 45 events. And 45 events is something we can deal with, right? Especially if we stack them, because then we don't have duplicates. So this is basically stacking, because as you can see, count by. So some of these have happened 2 times, some of these 1 time. In a production environment, there's of course a lot more going on, but we can already see there's whoami executed in the command line. We have FTK imager. We have, and this is where it gets interesting, Wireshark dumps. That's where we got the PCAP from, FTK imager. But as soon as we get a little closer down here, MSHDA update the .exe HDA. So this is where we found out about a suspicious command line. PowerShell with the hidden with the obfuscated payload. This is the suspicious command line. The compress archive, remove item, PowerShell again. And then we see Notepad was open to open up some document, project, internal TXT files. Might have been some user activity. There was more PowerShell, pulling stuff from the registry keys, the scheduled tasks here, system info, who am I? There's the more PowerShell. So as you can see, more and more stuff coming up. This is a really powerful one, the stacking. Just stack stuff by command line if you have it available or something else, but just looking at all the things that happened and then just pull from there is a pretty good way. And the one thing we kind of neglected was we also have network traffic, right? And we are not even sure about all the network traffic because we haven't really looked into it too much now, but we already know this is a suspicious IP address, right? So if I want to look at all the connections that were made to this particular IP address, we can do network events, which is event ID 3. And we have event ID 3. And in that event ID 3, we have a field called destination IP, which is our suspicious IP address. Now I just want to see all the ports that were used to this particular IP address. And we do time chart and count by destination port and go to visualization. This actually makes it pretty nice. Visualizes the amount of network of events that we captured connecting to port 1001 and to port 9001 and 9003. So we can see 1009 started early and had a bunch of events. So basically we can see 40 events in this minute, 40 events in this minute, 40 events in this minute. So pretty consistent beaconing still. And then later on, only here is when the port 9003 started to be connected to. And that is actually probably because, when we look back at what process is responsible for this, that's probably the second agent that we just discovered, the second PowerShell process. So that's a nice way to look at the different network traffic that we've observed so far. So which of the courses explains these kinds of advanced searches in detail? So the basics, the knowledge you need is in the 101 course. Forensics, Windows Forensics is covering forensic artifacts. What we do here, that's next. That's the 301 coming out very soon. I'm just showing some stuff here already that's going to be part of this. So stay tuned. We have a lot more coming up, but this is already just showing here some interesting stuff, right? So can we see whether data exfiltration actually happened, that 1.zip exfil? That's a good question. Let me answer that real quick because that's part of the scenario here, right? So it depends how 1.zip was exfiltrated. In our PCAP, we've already seen that we can see that we can have a graph, like visually we created a graph on the last session where you can see that there was a gap, there was actually a spike. There was actually a spike in traffic that went out. So if you correlate the timestamp with that, and if you correlate the process where we see when this file was 1.zip was created, the time, if they basically align, and then you have a big spike in your traffic, that is technically could be an indicator. It's not proof, but it's very likely, suggesting that this might be an exfiltration, depending on how big the 1.zip file was. But the other thing is 1.zip could have been exfiltrated in a lot of different ways, right? In ransomware cases, most of the time what they're using is FTP clients or tools such as rclone to go to mega.nc directly or something like that. And then you have traffic spikes, and you would have to look for a tool that was used to exfiltrate it, such as rclone. In our case, this file was not too big, and instead of searching for it and not finding anything, I can give it away right away. This was actually stuff that was exfiltrated through the command and control channel. So you wouldn't technically see 1.zip making its way out somewhere, except a traffic spike somewhere else. Question was there on the practical Windows Forensics 101, the same as practical on TCM. So yeah, I have a forensics course on TCM. It's the same as the 201 on the Blue Cape Security side, except Blue Cape Security has labs with it. So you don't have to download and install your own labs. And the 101 course is just available on Blue Cape Security. And the 301 course will also just be available on Blue Cape Security. So just the 201 course, the practical Windows Forensic has been around for a long time and actually started out with TCM Security, and I'm still partnering with them. So yes, you can have it. You can go there, take the course, but you would have to set up your own lab and download all the stuff. We just opted with Blue Cape Security to have it all this in-browser lab experience. So this is where the difference is there.